Hi, I'm Jacob Beck with Electrum Instruments. I'm going to show you how we do a test with the Electrum ITIG 2 Model D in manual mode. We have a motor hooked up. The clamps we use are Kelvin clamps on this particular model so that we can use the same leads and the same clamps to do low resistance measurements as well as high voltage surge tests, high pot tests, and also megohm tests. We do have a ground lead connected to the frame, which is required in the high voltage with the high voltage tests. When you turn on the ITIG 2 with the main power on-off button in the back of the case, this screen comes up. You click the start button and we are now on the first screen of the ITIG 2, used both in automatic mode and manual mode. Since we're in manual mode and we are going to do tests without saving the data, we click this button up here that says test without data save. That brings us to the setup screen, which has a formula on the top which tells you what voltage we will be testing to in the high voltage parts of the test. Today we're just doing a 460 volt motor here, so we're testing to 2 times operating voltage plus 1000, which gives us the number indicated here, 1920. You can also make adjustments to the overcurrent trip out used in megohm and high pot. We are going to leave those at 1000, which is what we have on the screen. So the first test we will do is the winding resistance measurement. To start the test, you can click in the fields here. Do one at a time, but we're going to do them all automatically in the sequence by pressing this button, the little triangle button in the corner. The little field turns green when it is active, and pretty soon a measurement appears at the screen, at the field down here. It takes a little while for it to stabilize, and depending on the resistance in the windings, that can take a few seconds or it can take up to 3 minutes. So it moved automatically now to lead 2 and 3. Takes a little while to stabilize again before it moves to lead 3 and 1. Once all 3 measurements are done, it will calculate the max delta R %. That is the maximum distance of one of these 3 measurements from the average of the 3 measurements. And in this case, it's 0.7%, which is a good result, and it's a good motor as far as winding resistance is concerned. In this case, this measurement was done at 20 degrees C. This temperature can be changed before or after you do the measurement. So let's say we have 23 degrees instead of 20. Click in the field and punch in the temperature. For example, instead of 20 degrees, 23 degrees. Enter. The numbers change. They're now corrected 23 degrees and the test is finished. So now we will move on to the next measurement, which is a megohm measurement, and do that manually. We simply press the start-stop button and dial up the voltage to 1000 volts, which is a very common voltage to use. Can also use maybe 500 for a 460 volt motor like this. This is a pretty good motor. It has very low leakage. We have the result here calculated at 40 degrees centigrade, as well as the absolute number, which is over in this display. When we're done, we just press the button again and the test is finished. Normally a megohm test per the standard is supposed to be done or held for a minute, but we are going to shortcut it here. We move on to the next test, which is the high pot test. It's essentially the same as the megohm test. We click the start button and dial up the voltage. Now we're going to dial it up to the design test voltage, which is calculated by that formula on the setup screen. Again, we should hold high pot for about a minute. We're not going to do that here, but again, we see that this is a pretty good motor. There is essentially no leakage current, and we turn it off and the test is done. You may have noticed that this message line down here turned when I shut the test off. It indicates there what the voltage in the windings are and tells you when it's down to basically 0 or below 30 volts. So you can safely go and remove the leads or touch the motor. The last test is the surge comparison test. We automatically start with lead number 1. We unlock it to start the test. The tester automatically finds what the sweep should be and what the voltage range should be, and drives the voltage up to the prescribed voltage, which is 1920, and shuts the test off. To test the next coil, we click on 2. I have to unlock it. Click the start button. We go to phase 3. Unlock, click the start button, and the test is done. We see that there is some slight separation. That could be an issue, but we also know that this is an assembled motor, and with an assembled motor we get rotor action and we'll get a slightly different frequency going from lead 1 through lead 3. We can now turn the rotor and repeat that last test to see if we can get the waves to line up, and they do. If you are familiar with testing assembled motors, you know that you need to turn the rotor to line up the waves to make sure that you have a good test. Let's call this one good. You can also get data on what the difference is between the waves. That's automatically calculated for you. It calculates a % wave difference to help assess the results. And that is the sequence for doing a manual test with an ITIG 2 Model D.